Welcome to this deep dive into Claude Code's built-in tools. Whether you're using Claude Code as a developer tool or building on top of it, understanding what tools are available and when to reach for each one makes the difference between a smooth session and a frustrating one. In this deck, we'll cover every built-in tool, what it does, its key parameters, and practical guidance on when to use it. We've organized them into 6 categories and wrapped up with an execution model, a selection guide, and a quick reference table you can use as a cheat sheet. Let's start with the big picture. Claude Code's built-in tools fall into 5 main groups: file operations, read, write, edit, glob, grep, and notebook edit. Cover everything related to reading and changing code on disk. Shell and web covers bash for running commands, and web search and web fetch for pulling in live data from the internet. AI and agents covers the orchestration layer, agent for spawning subagents, skill for invoking reusable prompts, tool search for discovering tool schemas, and ask user question for gathering user input. Task and planning has the task management tools, plan mode, and cron scheduling. And finally, MCP tools let Claude interact with external model context protocol servers. Before we look at individual tools, it helps to understand what a tool actually is under the hood. Every built-in tool has 6 fields: a name, an input schema defined in XOD that gets compiled to JSON schema, and 3 Boolean flags: is read-only, is concurrency safe, and is destructive. The flags are not just metadata. Is read-only is the most important one. Mark a tool read-only, and it automatically gets batched concurrently with other read-only calls, up to 10 at once. Leave it false, and the tool forces a serial boundary, everything before it must finish first. Is destructive triggers user confirmation, even in auto-approve mode. These flags are the primary orchestration lever. Read is the most used tool in Claude Code. It opens any file on the file system and returns its contents in cat-n format, with line numbers prefixed to every line. That line number output is important. It's what makes edit operations precise. By default, read returns the first 2,000 lines, but you can specify an offset and limit to read any window of a large file. It also supports images like PNGs and JPGs, PDFs up to 20 pages at a time using the pages parameter, and Jupyter notebooks, which it returns as all cells with their outputs. One key rule: you must call read on a file before you can edit it. The edit tool enforces this at runtime. Read is read-only true, so it batches concurrently with other reads. Write creates a new file or completely overwrites an existing one. It takes just 2 parameters: the file path and the full content to write. The most important usage rule is simple but easy to forget. Always read an existing file before writing it. Write will overwrite silently without warning. The decision between write and edit comes down to the nature of the change. If the file already exists and you're only changing part of it, use edit. It sends just the diff, which is more efficient and easier to review. Write is better for creating brand new files, generating config or boilerplate, or cases where you're replacing most of the content anyway. Write is not read-only, so it forces a serial boundary in the execution pipeline. Edit is the preferred tool for modifying existing files. It works by exact string replacement. You provide the old underscore string to find and the new underscore string to substitute. The key constraint is that old underscore string must be unique in the file. If it appears in more than one place, the edit fails. That's intentional, to prevent accidental multi-site edits. The solution is to include more surrounding context in old underscore string until it becomes unique. The replace underscore all flag lets you explicitly rename something across an entire file, useful for variable or function renames. Always read the file first so you have the exact text, including indentation, since edit requires character-perfect matching. Like write, edit is not read-only and runs serially. Glob is a fast file pattern matching tool built for any codebase size. You give it a glob pattern like /*star.ts for all TypeScript files and an optional root directory to search from. It returns matching file paths sorted by modification time, newest first, which is handy for finding recently changed files. The mental model for when to use glob versus grep is straightforward. Use glob when you're searching by file name or extension, and use grep when you're searching file content. Never use bash find or ls when glob can do the job. Dedicated tools give better user-facing visibility and correct permissions. Glob is read-only, so it runs concurrently with other reads. Grep is a full-featured content search tool built on ripgrep. The pattern parameter takes a regular expression, and you can filter the search to specific file types using the type parameter or specific name patterns using the glob parameter. The output _ mode parameter is worth understanding. Files _ with _ matches is the default and returns only the file paths where matches appear, fast and low noise. Content mode returns the actual matching lines with line numbers, and you can add context lines around each match using the -c parameter. Count mode tells you how many matches each file has, useful for gauging prevalence before reading. One gotcha. Ripgrep syntax requires escaping literal braces, so searching for interface curly braces in Go needs \escaping. Grep is read-only. Bash executes shell commands and is the general-purpose escape hatch when no dedicated tool fits. The key rule is, prefer dedicated tools first. If you need to read a file, use read, not cat. If you need to find files, use glob, not find. If you need to search content, use grep, not grep or rg. Bash is the right choice for running tests, builds, Git operations, package management, and system commands that don't have dedicated equivalents. The run _ and _ background parameter is useful for long-running processes like dev servers. You start them, continue with other work, and get notified on completion. One important note. Working directory persists between bash calls, but environment variables set in one call do not carry over to the next. Web search gives Claude access to live web search results, which is critical for any information that postdates the August 2025 knowledge cutoff. The main parameter is the query string. You can optionally restrict results to specific domains using allowed _ domains, which is useful when you want documentation from a particular source. Web search is read-only and can run concurrently with other read-only operations. One important protocol. When Claude uses web search results in a response, it must include a sources section citing all URLs used. This is a hard requirement, not a suggestion. Use web search for current library versions, changelogs, real-time status, and anything where the training data might be stale. Don't use it for codebase questions or stable knowledge that's already in training data. WebFetch fetches the content of a specific URL and processes it. The two parameters are the URL and a prompt describing what to extract or summarize. Under the hood, it fetches the page, converts HTML to Markdown, and then uses a model call with your prompt to extract the relevant content. HTTP URLs are automatically upgraded to HTTPS, and results are cached for 15 minutes, so repeat fetches of the same URL within a session are free. The key difference from web search is specificity. Use web search when you're looking for information and don't know the exact source, and use WebFetch when you have a specific URL you want to read, like a documentation page, an API reference, or a changelog entry. The agent tool lets Claude dispatch specialized sub-agents to handle complex tasks independently. You give it a short description, a full prompt with all the context the agent needs, and optionally a sub-agent _ type to select a specialized agent like Explore for codebase research or Plan for architecture planning. Background mode lets you dispatch an agent and continue with other work while it runs. You'll be notified on completion. The worktree isolation mode creates a temporary Git worktree so the agent works on an isolated branch that doesn't affect your working directory. The most important thing to remember about agent: each spawn starts completely cold, with no conversation history. Brief it thoroughly. Include file paths, what you've already tried, and exactly what you need. Terse prompts produce shallow work. Skills are reusable prompt files with YAML front matter that control their behavior and discovery. The front matter declares the skill's name, a description used for search, an optional whitelist of allowed tools, file path restrictions, and an optional model override. The prompt body is everything below the front matter, with $ arguments substituted at invocation time. Skills can run in two modes. Inline shares the parent's context and token budget, which is fine for quick lookups. Fork mode creates an isolated subagent with its own context. Failures stay contained and don't eat into the parent's budget. For anything that edits files or makes multiple tool calls, fork is the right choice. Claude Code discovers skills from 6 locations in priority order, from bundled skills down to MCP-provided ones. Tool search solves a specific problem. MCP tools and some built-ins are deferred. They arrive in the tool list as a name and description stub, without their full parameter schema. Claude knows they exist, but can't call them yet. Tool search lets Claude load the full schema on demand. There are 3 query forms: select : followed by comma-separated tool names for direct lookup, plain keywords for fuzzy search, and a plus prefix to require a term while ranking by others. Once tool search returns a tool's full schema, that tool becomes callable in the same turn. No additional round trip needed. The practical takeaway: before calling any MCP tool, always run tool search first with select : and the exact tool name. All MCP tools are deferred by default. Ask user question is how Claude gathers missing information from the user during a task. It presents a question and an optional list of choices. Single select gives the user one option to pick. Multi-select lets them choose multiple. The preview field can display an artifact, like a code snippet or image, alongside the question. One common pattern is including an other option in the choices list, which enables free text input when none of the presets fit. The key guidance on when to use it: call Ask User Question when there's genuine ambiguity that blocks progress and that the codebase can't answer. Don't use it for things you can figure out from reading the code, and don't use it to ask for approval of a completed plan. That's what exit plan mode is for. The task management tools give Claude a structured way to track multi-step work across a session. Task Create takes a subject, description, and optional active form label shown in the progress spinner. It creates the task with status pending. Task List returns all tasks at once. No params needed, showing status, subject, and dependency relationships. Task Get retrieves a single task by ID when you need full details. Task Update is the most important of the group. It lets you move a task through its lifecycle, from pending to in_progress to completed, and also lets you wire up blocking dependencies between tasks. Task Stop cancels a running task, and Task Output streams output from a running background task. The workflow is simple. Create tasks, mark in_progress before starting, mark completed when done. Plan mode is a 2-tool workflow for structured implementation planning. Enter Plan mode activates a read-only phase, where Claude can only use non-destructive tools, reading files, running explore agents, but not writing code. The goal is to produce a plan file with a complete implementation approach before touching a single line of production code. Exit Plan mode presents that plan file to the user for approval. Its allowed prompts parameter lets Claude request specific bash permissions needed to execute the plan, like running tests or installing dependencies. A common mistake is using Ask User Question to ask the user if the plan looks good. Don't do that. That's exactly what Exit Plan mode is for. It implicitly requests approval and waits for the user's response. The cron tools let Claude schedule prompts to run on a recurring schedule. Cron Create takes a 5-field cron expression in the local time zone, a prompt to run at each trigger, and a durable flag. Session jobs live only as long as the current session. Durable jobs are written to disk and survive session restarts, with a 7-day time to live. Cron List returns all pending jobs so you can see what's scheduled. Cron Delete cancels a job by ID. The 5 fields in the cron expression are minute, hour, day of month, and day of week, standard Unix cron format. A common use case is scheduling a daily status summary, a regular code review check, or a cleanup task that should happen on a timer rather than manually. Notebook Edit handles Jupyter Notebook editing. Notebooks are structured as arrays of cells, each with a type, code, markdown, or raw, and a source. The edit_mode parameter controls what happens. Replace overwrites the cell at a given index, insert adds a new cell before the index, and delete removes it. Always read the notebook first using the read tool on the .ipynb file. It returns all cells with their outputs, types, and 0 indexed positions, so you know exactly what you're working with. One important behavior. Notebook Edit does not clear cell outputs when you modify source. If you want fresh outputs, you need to rerun the notebook after editing. Notebook Edit is not read-only. Enter worktree and exit worktree let Claude create isolated Git worktrees for development work. A worktree is a separate working directory linked to the same Git repository but checked out on a different branch. Enter worktree takes a branch name to create, an optional base branch, and a directory path for the worktree. Changes in the worktree don't affect your current working directory at all. Exit worktree closes the worktree. If you set keep to true, the branch and worktree are preserved for you to create a pull request from. If no changes were made, the worktree is automatically cleaned up. The main use cases are feature work that needs isolation, executing plans in a separate branch, and running parallel agent tasks that each need their own branch. MCP tools are a category of dynamically loaded tools provided by external Model Context Protocol servers. MCP tool wraps any tool from a connected MCP server. Their schemas come from the server itself and follow the standard deferred loading pattern, meaning you must call tool search before invoking them. Tool names use the format MCP:\server name _tool name. McPauth handles OAuth flows for MCP servers that require authentication. It triggers automatically when a server returns a 401 response. List MCP free sources browses available resources from connected servers. And read MCP free source fetches the content of a specific resource by URI. The key mental model. All MCP tools are deferred stubs until you load their schemas via tool search. Let's pull back and look at how tool calls are actually executed. The execution model has 2 dimensions, parallelism and permissions. On parallelism, read-only tools batch concurrently, up to 10 at once. Non-read-only tools force a serial boundary. So in a sequence of glob, 3 reads, then edit, the glob runs first because it's not read-only. Wait, actually glob is read-only, so it runs. Then the 3 reads batch in parallel, then edit, runs alone. The permission pipeline has 5 layers. Input validation via the ZOD schema, the tool's own permission logic, centralized rules from Claude.md, pre-tool use hooks that can allow, deny, or escalate to the user, and finally, execution, followed by post-tool use hooks. Large tool results over 50,000 characters are saved to disk, with a short preview and file path returned to Claude. Here's a quick decision framework for tool selection. For file work, find files by name with glob, search content with grep, read with read, make targeted changes with edit, and create new files with write. For running things, use bash for tests, builds, and git. Use enter worktree for isolated feature branches. Use cron create for recurring automation. For web data, Web search for queries. Web fetch, when you have a specific URL. For orchestration. Agent for delegating complex multi-step tasks. Skill for invoking reusable workflows. Tool search before any MCP call. Ask user question to gather user input, and enter plan mode when you need to think before you code. The golden rule: always use the most specific tool available. Dedicated tools beat Bash, and purpose-built orchestration beats doing everything in line. This slide is a compact reference table covering the most important built-in tools. Each row shows the tool name, its category, whether it's read-only, which determines whether it can run concurrently, the key parameters you'll actually use, and a one-line description of its best use case. Keep this handy when building with Claude Code. The read-only column is particularly important if you're writing custom tools or agent workflows. Anything marked yes can participate in concurrent batches for free. Anything marked no forces the current batch to flush before it runs. For MCP tools, the read-only status varies by server, so check the schema returned by tool search. Let's close with 5 things to remember. First, prefer dedicated tools over Bash. Read, edit, glob, and grep are purpose-built, permission-aware, and give users better visibility than raw shell commands. Second, always read before write or edit. Edit enforces this. Write doesn't, don't skip it. Third, mark custom tools is read only to get free concurrency. It's the single most impactful flag for performance. Fourth, use tool search before calling any MCP tool. All MCP tools arrive as stubs. Tool search unlocks their full schema in the same turn, so you can call them immediately after. And fifth, skills and agents are scoped sub-sessions, not just prompts. Fork mode gives them isolated context, their own budget, and sandbox tool access. Use fork whenever a skill edits files or runs more than one tool.